Let's continue part 2, 2026 January, Chemistry, Unit 2 paper. Right. So we'll go for question number 9. So here they are talking about what is the value of N needed to balance the equation shown. So here I have to go through some theory parts. So we have to balance this equation ClO3 minus plus H plus electrons gives you Cl minus. But I'll teach you step by step how we do this balancing part. So this is a reduction reaction. So ClO3 minus, when you look at it, you can see chlorine has oxygen here at the reactant side. In the product side, chlorine does not have oxygen. So it's a reduction. So the first thing they are saying that first identify whether the reaction is an oxidation or reduction. That's for your reference because it's easy for you to do the next part of the question. But since it's the MCQ, so this step you don't need it. Then step 2, first balance the central atom. So central atom is a main atom where you can see in the both side. So here is chlorine, one chlorine atom and one chlorine atom here also. So you don't need to perform that step because it's already balanced. Then the third step they say that balance the number of oxygen atoms by adding water molecules. So if I write this equation again, so I have ClO3 minus. So on my reactant side there are 3 oxygen atoms. But on my product side there are no oxygen atom. So what they say is balance the number of oxygen atom by adding water molecules. So here you have 3 oxygen atoms. So therefore I am going to add 3 water molecules into this side. So one water molecule has 1 oxygen, 3 of them will have 3 oxygen. Now the oxygen is balanced. Then balance the number of hydrogen by adding H plus ions. So here you can see that because we add water, we have 6 hydrogen atoms on this side. To balance 6 hydrogen atom, I have to add 6 H plus ion on this side. They say balance the hydrogen atoms by adding H plus ion. 6 hydrogen here, so therefore we have to add 6 H plus on this side. Cl minus plus 3H2. Then the last step, balance the charge by adding electrons. Electrons are negatively charged, so you have to add electrons in order to balance the charges. If I look at my product side, there's only one Cl minus ion, so its charge is minus 1. If I look at my reactant side, ClO3 minus is minus 1 charge. H plus ion is plus 1, there are 6 of them. So plus 1 times 6 is plus 6. So this side is minus 1, this side is minus 1 and plus 6. So if I want to make these charges equal, so best thing is make this minus 1 equal to minus 1 here. So minus 1s are already in both sides. So only way we have the problem here is if I remove this plus 6, then the charges will be balanced. How to remove by plus 6? The best way is add minus 6. How do you add minus 6? Electron is minus 1. So if you add 6 electrons here, then the charges will be balanced. So you have to add 6 electrons there. So therefore answer for question number 9 is C. Now you might be thinking, do I have to do all these steps? No, because the reason is the question has done most of the stuff for you. See, H plus, everything is balanced. They're asking how many electrons are there. That's the only part they're asking. So simply you have to balance the charges. So we can see this side bar charge is minus 1. This side you can see minus 1 because of ClO3 minus and plus 6 is there. So therefore we know that if you want to make these charges equal from both sides, so what you have to simply do is remove this plus 6. How to remove that plus 6 is just by simply by adding minus 6. So minus 6 plus 6 cancel out. Then minus 1 and minus 1 is equal. So that means this electron carries minus 6. So therefore N should be 6. That's why my answer is C. So in the exam you don't need to perform all these steps. Just performing the balancing charge, the final step is enough. Now question number 10. This question is about industrial chemistry. The Haber process for manufacture ammonia use the reaction shown. Okay. Now here they are talking about Haber process. If you can't remember it, no worries. Because they are not asking about the Haber process, they are asking something else. They are talking about manufacturing ammonia. Enthalpy change is negative. Okay. Which change will not increase the rate of the forward reaction. Now remember, they are not talking about shifting the equilibrium. So just try to mix you up with the equilibrium and the rate. So remember, here they are talking about rate. So we don't go through the answers, we just first remember what are the factors affecting the rate of the reaction. As I can remember, first factor affecting the rate of the reaction is temperature. So we learn that higher temperature, higher rate, lower temperature, lower rate. Then the second thing is, if it is a gaseous reaction, these are gases. Second one is pressure. High pressure, higher rate, low pressure, lower rate. The third thing I can remember is particle size. Particle size, fine particles. If the particle size have more surface area, if they are like powdered form, then the rate is higher. So one is particle size. Then another factor we can remember is concentration. How many particles in a given area, so in a given volume. So concentration is there. If the concentration is high, rate is high. If the concentration is low, rate is low. Then the last one is catalyst. Presence of a catalyst will speed up the reaction because it provides an alternative path with lower activation energy. Which change will not increase the rate of the reaction. Okay, let's see. Decreasing the size of the catalyst pieces. Decreasing the size of the catalyst. Okay. That's a question mark. Obviously, we know the presence of a catalyst, yes, increase the rate of the reaction. But decreasing the size or increase the size of the catalyst, we have doubt, but we know that if more surface area, the catalytic activity will be higher, but it's a question mark because we haven't discussed that part in our in our syllabus. So therefore we'll leave it as a question mark. We don't know exactly for sure, but it makes sure that it makes sense, but we'll keep it a question mark. Increase the pressure. Obviously, it's a gaseous reaction. When you increase the pressure, what will happen? High pressure means particles will fly close to each other. When the particles are close to each other, there can be collisions, more collisions. More collisions mean more successful collisions. That means frequency of successful collision increases, therefore rate of the reaction increases. That means more collision means the rate of the reaction increases. That's correct, but we are asking will not. Increase the temperature. Obviously, we know that temperature increases, the kinetic energy of the particles increases, therefore frequency of successful collision increases, and therefore rate of the reaction increases. Removing the ammonia acid formed. If you keep on removing ammonia, equilibrium shift to the right hand side, but it doesn't have anything to do with the rate. Rate depends on these factors. So I think this will not increase the rate of the reaction. This was a question mark, but even though it's a question mark, it has two things. They add a catalyst and they make it small particles. So obviously we know that catalyst will increase the rate of the reaction. Smaller particles will increase the rate of the reaction. I don't see any factor this will result decreasing rate of the reaction. So therefore our answer is answer D for question number 10 part A. Now you might be thinking we get question like this that we don't have any idea at all. Actually you do have idea, but you don't have perfect idea. But the thing is, you can see the question paper, they never ask you to find the right answer. They ask you to find the most suitable answer. They ask you to use your knowledge, existing knowledge, and find the most suitable answer. From the existing knowledge we have, the most suitable answer for our question is answer D. Right. Then question number 10, part B. During the Maxwell process, can't remember Maxwell process, you don't know Maxwell process, no worries, because they are not asking about the Maxwell process. When ammonia is converted to nitric acid, they tell what is Maxwell process. It's a conversion reaction where it's a process where we convert ammonia to produce nitric acid. Several reactions occur. They say that during that process, several reactions occurs. Which of the reaction has the greatest change in the oxidation number of a nitrogen atom? They don't talk about this process, they are talking about greatest change of the oxidation number of nitrogen atom. Okay, let's see one by one. If you take the first one, nitrogen oxide. Okay, nitrogen monoxide is there. Nitrogen oxidation number is X. Oxygen is usually -2. So X plus -2 is 0. So if X plus -2 is 0, we know that X equals +2. So first one, nitrogen oxidation number is +2. Then next one is NO2. If we do the math for NO2, nitrogen is X, oxygen is -2. There are two of them. 2 times -2. That means -4. So X plus -4 equals 0. So therefore X equals +4. So this is +4. Greatest change. So +2 become +4. The change is +2 because +2 + 2 is +4. There are the changes has happened by +2 by two digits. So that means 2 became 3 and 4. So that's where the change we get for the answer A. If you go for answer B, NO2 nitrogen oxidation number, we know it is +4. So this is +4. It became HNO3. HNO3 means hydrogen is +1. Nitrogen we don't know. Oxygen is -2. There are 3 of them. So it's 3 times -2 equals 0. So -3 times 2, 3 times -2 is -6. -6 plus 1 is -5. So it simply say that X minus 5 equals 0. So X equals +5. +4 became +5. The difference is just +1. The difference between those two numbers. So just add one number, then you get +5. Okay, that's not as much as the first one. Second one, third one. See, NH3, if you take NH3, oxidation number of nitrogen is X, hydrogen is +1. So there are 3 of them. So it will be 3 times +1 equals 0. So X plus 3 equals to 0. So therefore X equals -3. So nitrogen is -3 here. Nitrogen monoxide, this is +2. -3 +2. The difference between those two numbers are +5. So you know that the number line, right? So if I draw the number line, so we have 0 here, and we have -1, -2, -3. So here +1, +2. So if you're in -3, that means here, to go to +2, you have to climb 1, 2, 3, 4, 5. 5 digits. That's why we call it difference is +5. Here ammonia, nitrogen is again -3. Nitrogen is an element, so it's 0. -3 to 0, difference is 3. So therefore our answer is C. So since even though I did this calculation, but when you are doing it in the exam paper, you have to do it mental math, right? So you have to do more practices. Just by looking at the compound or molecule, you should be able to tell the oxidation number of each species. So answer for question number 10B is C. Right. Then we'll go for question number 10C. Okay, part 10C. One step in the contact process to produce sulfuric acid, use the reaction given shown. Okay, this is a reaction. The reaction is carried out at 450 degrees Celsius and pressure. So they say that temperature is 450 degrees Celsius. Pressure is 2 atm. Our catalyst is vanadium oxide. Vanadium oxide. So it's V2O5. Which statement is correct for this step? At a lower temperature, the yield of SO3 decreases. Okay, first two things, they are talking about temperature. Okay, we'll leave it. Which statement is correct for this step? We'll keep the two temperature statement for a while and we'll go for other one. At high pressure, the yield of SO3 decreases. When the pressure is high, so we can see that on our reactant side, there are 3 moles of gases. On the product side, there are 2 moles of gases. So when they are talking about yield, they are talking about when you have a reaction, a reversible one, whether you can shift the equilibrium forward or backward. Forward means the product side, or we call it right and left. Okay, whether you can shift the equilibrium right hand side or the left hand side. So what will happen at high pressure? The yield SO3 decrease. High pressure means, so let's take you have particles, right? Okay, then increase in the pressure means, one way you can increase the pressure is by reducing the volume. When the volume is reduced, particles will compact to each other. So here you have 1, 2, 3, 4 particles. But when the volume increases, now those 4 particles are lying very close to each other. So therefore what will happen? The pressure is high. So when the pressure is high in a reversible reaction, an equilibrium, which is in equilibrium, the fact you have to remember here is always the system will react against the change. So that means you can say that the system is counter-react against the change. So this is what will happen. We increase the pressure now, so the system will try to decrease the pressure. How to decrease the pressure is, now they can't do anything with this container. So one thing they can do is, they can withdraw few particles. So let's assume you have 5 particles here. Now when the pressure is high, what they can do is, they can remove 1 particle from it, make it 4. How can you do it that way? Because you can see that in the equilibrium, in the left hand side there are 3 moles of gas, but on the right hand side there are 2 moles of gas. So if I keep on producing products of the right hand stuff, I'll get less number of gaseous moles. So that's what they are saying, that at higher pressure the yield of SO3 decreases. No. When the pressure is high, to reduce the pressure, equilibrium will shift towards right hand side to producing more and more SO3. So therefore yield of SO3 will not decrease, it will increase. So this statement is wrong. They are asking the correct one. At a lower pressure, the cost of reaction vessel increases. At lower pressure, the cost of reaction vessel increases. You can think that, let's assume that you are going to store a gas in a container. One way you can store gas in a balloon, a little bit of gas. But you can see, if you look at your homes, we have something called liquid petroleum gas, LP gas cylinders. Some houses, they might be getting this one from the direct line, but most of the houses, like many parts of the world, when you want to like have a cooking using LP gas, liquid petroleum gas, they have this type of cylinders. So inside this cylinder, sometimes you get gas which is enough for 1 month or like few weeks. So that means this gas, there's a lot of gas inside this. That means they have put the gas in high pressure. When the gas is in high pressure, if you touch the wall of this one, some countries they have made this one in metal, and some countries they have made it in very thick plastic. The reason why they have done is because when the pressure is high, to hold it you have to have a container which has very thick walls. So at lower pressure, the cost for the reaction vessel increases. No. At the lower pressure, if the pressure is low, you can have your gas even in a balloon. But in the pressure is high only, you need like big containers, like thick containers. At lower pressure, the cost is high. No. At lower pressure, cost is low because a thin wall can hold this gas. But at higher pressure only, you need thick wall to hold this gas. So therefore what will happen? High pressure only your cost is high. Lower pressure, you can have your gas mixture at anywhere. So this statement is also wrong. Now let's go for the temperature story. Right. So that means we know that C and D are not my answers. So that means my answer should be A or B. So let's go for our issue with the temperature. So what we have is 2SO2 plus O2 reversible reaction producing SO3. They say that enthalpy change is negative. Negative means exothermic reaction. In the forward reaction, they give out heat. They are giving out heat. So who will like to give out heat? A reaction will like to give out heat when the outside temperature is low. Because in the outside does not have heat, what will happen? You will try to give heat to them. So because the reason is the system again acts or counter react against the change. If you decrease the temperature, now there's a change. What is the change? Temperature is lowering down. The system will counter react. It wants to increase the temperature. How to increase temperature? Give out as much as possible heat. So therefore, in a reversible reaction, lower temperatures, forward reaction, giving you more SO3. At lower temperature, the yield of SO3 decreases. No, it is increasing. At lower temperature, the catalysts do not work efficiently. So A is strong, C is strong, D is strong. Obviously, we know that B is our answer. But we'll see for that one. We read B also. At lower temperature, the catalyst does not work efficiently. Yes. Now here, this lower temperature, they are not going to related to equilibrium. So our D, C and A, they are talking about the equilibrium. They shift forward or backward. Now using our factors, we discuss, okay, lower temperature, if reaction is exothermic, it like to give out heat. When the pressure is high, it like to produce less moles of gas. And the next thing is, answer B, they are not talking about equilibrium. They are talking about rate of the reaction. At low temperature, the catalyst does not work efficiently. Catalyst has nothing to do with the equilibrium. It's only work on the rate of the reaction. We learned that catalyst is one factor affect the rate of the reaction. So at lower temperature, the catalyst does not work efficiently, which is a question mark. Yes, that's the truth. It does not work efficiently. That's why our answer for question number 10C is answer B. Now you might be thinking, we haven't learned anything about how catalysts act when the temperature is lower. But the thing here is, they are testing our knowledge on equilibrium. So we definitely know that A is not my answer, C is not my answer, D is not my answer. But you know that when the temperature is low, rate of the reaction is lowering. So that means this statement might be something which can be true. But they are not asking the right answer, they are asking the most suitable answer. So since we know that A, C and D cannot be answers definitely, so answer is B. That's what we are going to discuss in these sections. So if you have any doubts on this part which I have discussed, you can just type a comment. So then I'll put a new video of discussing the rate of the reaction and equilibrium separately. Then you can go through that theory part. Okay. If you have any doubts on this theory section, just type. I want like clarification on this one. So then I'll make a short video on that. Okay. Then question number 11. The diagram shows Maxwell-Boltzmann distribution curve for a gas at two different temperatures. It's just like your exam marks. So let's assume you are sitting for the exam. And here you have the mark as the percentage, your mark. So you can see here the number of students who got that mark. You can see that if you take the marks 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. You know that there are very few students get 10 marks. Very few students get 20 marks. Very few get 30. Majority of your friends will get 40, 50 and 60 marks. Again, very few get 70, 80, 90, 100. So if you draw the graph of a distribution of energy of a gas particle is same as the graph that you see when you take the term test marks of your classroom. Less students get less mark, very less students get higher marks, majority of them will get average mark. Same story comes for energy for gases. So this is the same story, they have it here. Which present the most probable energy of molecules at lower temperature. Right. So I'll explain that part So if you take energy distribution of a gas sample, so this axis is energy, this axis is number of or fraction of molecules. Fraction of molecules. So if you take the energy, like distribution of energy, it's look like this. And there's a one small thing I want to emphasize. Remember, on this end, the graph never touches the x-axis. The reason is we don't know what is the maximum energy of a gas sample. So then what will happen? Let's assume this is T1 temperature. If I increase the temperature, I'm going to make it for new temperature, which is T2, higher temperature. When the temperature is higher, the energy of particles will increase. Then which way the graph will shift? This way. So our new graph at higher temperature will look like this. Okay, that means this is T2 temperature. That is the higher temperature. So we have two graphs. T1, T2. So T1 is here. T2 is here. Because when you are shifting this direction means your energy is increasing. Which represent the most probable energy of molecules at lower temperature. We know the lower temperature is this graph, the first graph, and the most probable energy for this lower temperature, we know that this value is not the value. What is this? Fraction of molecules. They are asking what? Most probable energy. Energy is where? In the x-axis. So we have to go down. Alright. In this graph, go down. This is the value of energy. So our answer for question number 11 is answer C. See how they try to trick you. Most of the students will mark it as A. But remember, they're asking what? They're asking energy, right? Not the fraction of molecules. So therefore, our answer for question number 11 is C. Question number 12. When dissolved in water, compounds of vanadium-2 form a solution that is purple in color. Okay, vanadium-2, let's assume is purple. In sealed system, the solution formed becomes a green as the equilibrium is established with vanadium-3 ions, which are green. Okay, so we have purple here. So we know that this is purple. This is green. And there's the equilibrium. Which change would make the solution more purple after equilibrium has been re-established? Okay, how to get more purple color? That means I have to shift the equilibrium backward, right? Okay, because then only I get more purple. I have to shift it to the left hand side. Addition of a reagent that removes vanadium 3 plus ion. If you remove vanadium 3 plus ion, what will happen? The system will try to counter-react. How to counter-react? Produce more vanadium 3 plus ion. That means shift the equilibrium towards right hand side, which will not increase the purple color, it will increase the green color. That's wrong. Next one. Addition of an acid. If I add the acid, it will decrease the concentration of OH minus ion, because OH minus ion react with H plus ion, producing water. Therefore, OH minus ion concentration decreases means the equilibrium will try to produce more OH minus ion, shifting the equilibrium right hand side, giving you more green color. That's also not our answer. So therefore, this is also not our answer. Allowing a hydrogen to escape acid form. Hydrogen leaving the system means again the equilibrium will try to produce more hydrogen, shifting the equilibrium right hand side. Okay, that means you get more green color, not more purple. If A is not our answer, B is not our answer, C is not our answer, C is not our answer is D. Let's say increasing the pH of the solution. If I increase the pH of the solution, more pH means more OH minus ion. More OH minus ion means system will try to decrease the OH minus ion. How to decrease the OH minus ion? Shifting the equilibrium towards left hand side, giving you more purple color. So therefore answer for our question is answer D. Right. Question number 13. Geraniol is produced by a sweat glands of honeybees and is used to mark the entrance to their hives. The structure of geraniol is shown. New knowledge. So geraniol made by honeybees. Okay, this is the molecule. Which statement about the geraniol is not correct? It changes hot acidified potassium dichromate from orange to green. So they are saying that when you add acidified potassium dichromate, it will change orange to green. Yes, it is. How do I know that? This is a primary alcohol. We learned that for a primary alcohol, if I add acidified potassium dichromate, what they will do is acidified potassium dichromate provide oxygen atoms. It's like oxidizing agents. This oxygen atom grab these two hydrogens, forming water, giving you an aldehyde. So therefore our alcohol get oxidized to aldehyde, a primary alcohol get oxidized to aldehyde, and our acidified potassium dichromate will reduce to chromium 3 plus ion during this process. So this is oxidation reaction, this is a reduction reaction. Dichromate is orange color, chromium 3 plus is green color. Therefore what will happen? It will change the color from orange to green. That's correct. It contains 3 CH2 groups and 3 CH2 groups. 3 CH2 group, yes, here this is CH3. We know that these are skeletal formulas. Since they are skeletal formula, if you don't see any other bonds, that means they are linked to hydrogen atoms. So this is linked to hydrogen. Okay, because carbon should have to have 4 bonds. 3 CH3 groups, yes. Do we have 3 CH2? This is carbon. Yes, it has CH and CH. This is carbon, CH, CH. When you have double bond, you can't have CH2 because here we can have only one hydrogen. But if you take, because carbon can have maximum 4 bonds. But if I take here, this carbon has 2 bonds already, other 2 are hydrogen. Yes, 3 CH2 groups. That's correct. It decomposes a small volume of bromine. When you add bromine to a double bond, what will happen? Double bond opens up and it will decolorize the color of bromine. What will happen? Double bond open up. So this double bond is an addition reaction. So now we don't have double bond, we have the single bond. 2 bromine atoms goes there and attach to these carbon atom where they had the double bond. So now we have one bromine is here, other bromine is here. That's a test to identify alkenes. If A is a correct statement, B is a correct statement, C is a correct statement, our answer for question number 13 is D. It exists as 2 pairs of cis-trans isomerism. I don't think we need to do that because it takes as 2 pairs of cis-trans isomerism because it's not the correct answer. If you want to, we can say it. Here obviously it can't show cis-trans isomerism. Why? Because this is a CH3 group, this is a CH2 group. We discussed to show cis-trans isomerism, you need 2 requirements. Number 1, there has to be a double bond. Number 2, either side of the double bond, then I discuss, it's not only the double bond, but for now, for AS level, knowing that there has to be a double bond, that's enough. Number 2 is, either side of the double bond, there has to be 2 different groups. If this group is A, this group has to be B. If this group is A, the other group has to be B. So these 2 should be different. One carbon atom cannot have the same group, but here is the same group. So there is no pair of cis-trans here. There can be cis-trans here. This double bond has a possibility because it has 4 different groups attached to it. So therefore we don't have 2 pairs of cis-trans isomerism, we have only 1 pair from here only. So therefore answer for question number 13 is D. Right. Question number 14. The compound shown is used as both an artificial sweetener and the laxative. Which functional group may be produced by oxidation of this compound? Which functional group may be produced by oxidation of this compound? Okay, they are going to oxidize this compound. when they are going to oxidize this compound, they are asking what are the products we can get. Okay. To explain this one, first I'll draw its displayed formula. So here we have OH group. OH here, CH2 is a primary alcohol. OH here, H is a secondary alcohol. OH here, secondary alcohol. OH, H, secondary alcohol. OH, H, secondary alcohol. CH2, OH, primary alcohol. So remember, primary alcohol, if it is a primary alcohol, they can go to two options. I'm not going to draw it here, I'll just draw it here. So now we have primary and secondary now. So primary, what will happen here? Primary means there's a R group, CH, H, OH. Oxidation means adding an oxygen atom. When you add an oxygen atom to a primary alcohol, these two hydrogen atoms will go first, forming water molecules. So what you get? An aldehyde, R, C, O, H. And they have another step called further oxidation. Another oxygen atom can jump here, forming a carboxylic acid. So you have aldehyde is also possible, carboxylic acid also possible for primary alcohol. So this is called aldehyde. This is carboxylic acid. If you go for secondary alcohol is this one. COH, there are two R groups there. For secondary alcohol, when you add the oxidizing agent, two hydrogen atom goes from here, and you will get forming a water molecule, and you will get a ketone. So R, CO, R. So this is a ketone. So that means in here we can get aldehyde, carboxylic and ketone. All three are possible. Aldehyde, carboxylic and ketones. Yes, our answer for this question is answer B. Question number 14, answer is B. Question number 15. Cyclohexane is both immiscible with water and less dense than water. Okay. It can be used to extract iodine from an aqueous solution. Cyclohexane is added to a separating funnel containing an aqueous solution of iodine. The funnel is shaken and the liquids are allowed to separate. So we have separating funnel. Separating funnel is something like this. Structure is like this, and there's a tap at the bottom. Okay. Cyclohexane is both immiscible and water and is less dense than water, right? So if they form two layers, water will be the bottom layer because it is less dense than water. So this is our cyclohexane layer. Right. It can be used to extract iodine from aqueous solution. Yes, iodine is a little bit purple. Purple, yeah, we can call it yellow color in aqueous solution. Let's assume we have iodine here. Iodine is more soluble in cyclohexane. Why? Cyclohexane is non-polar. But what is a polar solvent? Iodine is also non-polar. So remember, non-polar likes to mix with non-polar most. Even though there are one or two molecules of iodine, the cyclohexane layer will be full of iodine molecules because iodine is non-polar, cyclohexane is non-polar, non-polar mix with each other. So there will be massive amount of iodine molecules accumulate in the cyclohexane layer. That's what will be the situation. What is the best description for the color of the two layers? Right. So we know that obviously cyclohexane layer will be full of iodine. So when iodine in organic layer, we know that it's purple color. So iodine is purple color. So there is only one answer with purple color. So one answer with purple color, that means answer D. All the others showing something else, because iodine in organic layer, remember, is purple, right? Then, but why this lower layer? Obviously, there's no lower layer with colorless, no? Because the reason is, even though water is polar, some amount of iodine will remain there, because this is also equilibrium. This part is also an equilibrium. In A2 level, we are going to discuss about this equilibrium. But for now, remember that some amount of iodine can remain in water. Majority of the iodine will be in cyclohexane layer. So therefore, we can have few iodine molecules in water. So therefore, we can see yellow color in our aqueous layer. So lower layer is yellow color, upper layer is purple color. Answer of question number 15 is D. Now let's go for last one. Okay. NMR. No, sorry, it's IR spectroscopy. NMR comes in A2 level. 2-iodopropane can be converted via propan-2-ol into propanone. Okay. They are going to do a reaction. Infrared spectra and mass spectra were recorded for each compound. For 4 of 6 spectrum are shown. Okay. Okay, so we have infrared spectra, IR1, IR2, mass spectra. Which of the two spectra are the same compound? Use your data booklet in making your choices. Okay, so they are suitable. Okay, let's find that one. Each compound. Right. Iodopropane can be converted into propan-2-ol. Okay, first, when you get a question like this, I remember only two things. That's first, I'll tell you that part. No need data booklet. I know this part. If I have a OH bond, there'll be a broad peak around 3000 to 3500 wave number. 3000 is roughly around 300, but I'll say 3000 to 3500. I'll get a broad peak for OH bond. If I have a carbon oxygen double bond, there'll be a sharp peak like this at around 1650 to 1800. Within this range, I'll get it. That's the thing. Only two things I'll remember when I do AS level papers, because nothing else will come. Like, you will find out in IAS spectroscopy when you do AS level papers. So these are the only two things you have to remember. Let's use this knowledge, and before that I have to do something else. Iodopropane, I have to write them 1, 2, 3 propane, 2 iodopropane. So this is 2 iodopropane. This is our reactant molecule, first molecule, right? 2 iodopropane. First convert into propan-2-ol. Propan-2-ol. 1, 2, 3. OH here. H. 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 And propanone. Okay. Propanone means it's a ketone. Okay, then it gets oxidized to propanone. Okay, I know how to find I can exactly remember molar weight of 2 of them. Propanone, if I add them, 3 carbon atoms, carbon is 12. I just tell you the values. Carbon is 12. Hydrogen is 1. Oxygen is 16. Iodine, I can't remember. I think it's 127. Not sure, because I don't have a period table at this moment. I just cut it off because I don't know. So I need to tell lies. So I just cut it off. I think it's very close to 127. I think, right? So here, if I do the math, 3 carbon atoms, 12 times 3 is 36. 36 plus 6, 42. 42 plus 16 is 58. Molar weight of this one is 58. Molar weight of this one, 3 carbon is again 36. 36 plus 8. Yes, 36, 6, 7, 8. Yeah. 36 plus 8 is 44. 44 plus 16. So 44 plus 16 is 60. I hope I'm not using the calculator. Okay, 60, yes. Then this one, I don't know, but it should be more than 100, no? Because there's iodine atom, no? 100 or more. So first thing you have to remember here is, when you take mass spectrums, check the most right corner peak. The most right corner peak, we call it the peak which appears on the most right hand side. That's called most right corner peak. So when I look at it, I can see that the peak at the last point, that tells you the molecular ion peak. It's equal to the molar weight of your molecule. Right, for an example, if I name these molecules, I'll take this 2-iodopropane, okay, I'll write their names, okay. Then I can see in this MS2, its peak appears at 58. That means they are talking about this is propanol. This is propanol. Then we'll go for next one. Our next one is so we have propanol here. So I know that propanol is here. Now in the next one, when I check the molecular ion peak, it's somewhere around 164 something. Let's check with this 127 thing, because I know that it can't be this alcohol. So let's take whether it's 100. I'll check iodine as 127. So therefore we have 127 plus 3, 130. Yes, 130 plus 30, 166. 166 plus 4. Yeah, 164. No. Very close. It's 160 plus something. 100 is close to 170 comes here. Yeah, I think when I do the calculation, let's see, 120 to 140. So there's like difference of, yeah, we can be, yeah. So it's very close to 170. So I think according to our calculation, this should be, obviously it can't be this one. So you don't need to even check for the period table, because it can't be 60. So 58 we just found it. So this should be 2-iodopropane. Okay, now I have the two stories. So I don't need to worry about this, right? So therefore, none of them cannot have OH group, because they are asking mass spectrum and IR spectrum. I have to match it, because can you see in this IR spectrum, there's a OH group here. Yeah, I just told you 2 peaks I'm remembering. So therefore, obviously I know that 2-iodopropane, this combination never matches, because we don't have the mass spectrum of propanol. So this is out of the story. Okay, now I have two options. Either mass spectrum 1 should go with IR spectrum 1, mass spectrum 2 should go with IR spectrum 1. So that means these two are the only possible options I have. Okay, so when I look at this mass spectrum 2 means we are talking about propanol. Propanol has carbon oxygen double bond. So which means I should expect a peak around 1000, sharp peak around 1800 to 1650, which I can't find. So that means this mass spectrum 2 does not go with this IR spectrum. So therefore, the only option I am left out with is iodopropan going with this one. So therefore, I think mass spectrum 1 goes with IR spectrum 1. That means iodopropan is the mass spectrum. IR spectrum of that one is also iodopropan. So therefore, I am going with my answer A. Why did I go with answer A? Obviously, from the molecular ion peak, I found that this is iodopropan, because none of these molecules will have a molar weight close to even 100. So therefore, here we get something around 170, very close to. So that means I think this is iodopropan. If it is iodopropan, it cannot have the peak of the alcohol. So this is the OH peak. So therefore, it has removed. And it cannot have peak of this carbon oxygen double bond, where you can get the sharp peak very close to 2000, slightly below 2000. It's not there. So therefore, you don't need to find the peak of halogens. You can simply say that it's the combination of these two. because the reason is they says find the most suitable answer. Therefore, don't go through the tables and everything. I did this question without the help of the period table, without the help of the data booklet. That's how you have to find the answers for when you are doing MCQs, because you don't have much time to waste. Okay, now I'll tell you one more thing, how we can learn about these things. So we discuss chemistry Edexcel unit 2 paper January 2026, and next time if you have any doubts, I know these theories are a little bit confusing, you might have doubts, you won't find some clarification, you just type what is the topic you want to discuss. I'll make a small note on that topic and I'll make a small video of that, then I'll upload it. And the next thing is, next we are going to start discussing unit 4 as well as unit 5. In unit 4 and unit 5, I'm going to use about some techniques where you can remember these colors and these theory parts very easily. So if you have any doubts, simply what you have to do is just leave a comment, then I'll give you the answer in the next video. Thank you.